Hello everyone, hope you're doing and welcome back to my channel. Today we are at day 16 of the January daily lead code challenge, and we again have a medium question in front of us. This is the second day in which we are getting a bit manipulation question. Yesterday we had very good question, and the solution that I showed you yesterday, that is for day 15 of the January daily lead code challenge, it was beating 100% of the test cases. It was of one solution in terms of space and time complexity. So if you have not seen day 15th video, please go and check that out. My solution, I'm very proud to say, was beating even the most optimal solution given by LeetCode itself. Okay, so it was even beating the official solution. So please go and check out yesterday's video if you have not done so. And now coming to today's question, it's again a very nice question. And remember here one thing: many people will be uploading videos for these kind of questions, but remember one thing: they will be showing you the optimal approach, but no one will be showing you the approach that you should be coding in an interview. Okay, remember the optimal approach you may not be able to get or crack in an interview, but you should have something which is slightly less optimal than the optimal solution, but you should be able to submit all the test cases. Like you should be able to clear all the test cases. They will not be showing such a solution. So in this particular video, I will show you two solutions. One will be like everyone will be showing you the optimal one. Optimal will be okay. This is a tricky question. For that reason, there is optimal solution also, which requires a lot of trick and basically some mathematics also. But again, not everyone will be able to know that much tricks. Remember that if let's see, first thing is when such a question comes in interview. Okay, if you are knowing the trick, that is well and good, but again, let me tell you this very frankly. If you are able to get to the optimal solution in one go, okay, the interviewer will not believe that okay, you are not seeing this question. Okay, they will feel you have already known this question before, and that's why you will not get your credits. For that reason, optimal solution should only come after a after some less optimal solution. But still you will be required to get the solution, that is you have to clear all the test cases using at least some solution to start with. Okay, you can call it a brute force solution or slightly above brute force or something like that. Okay, but you should not be trying the optimal solution in the first go, as simple as that. So I will be showing you two solutions today that you can think of. Okay, the last solution will be the most optimal one, and the before that I will be showing you one solution that is clearing all the test cases that you can also submit, but again, it is not that much optimal. Okay, as simple as that. Now coming to the question, see this part. You are okay, 2425 bitwise XOR of all pairings. Okay, so what we are given basically two integer arrays called nums1 and nums2. Okay, it's a very like question is very small here. Just see the constraints first. The length of that is the total length is going to be around 10 power 5. That is, we are going to be having 10 power 5 elements in each of the arrays in the worst case. Okay, and each of the okay values is going up to the range of 10 power 9. Okay, as simple as that. Now coming to the question. So, yep, like one more thing I want to tell you, whenever you see these kind of constraints, right? Bit connection question. In yesterday's video, also I've done the calculation, showed it to you. Always calculate, see, for having this such a big value, how many bits will be required. Okay, so integer in Java and C++ usually have 32 bits. Okay, out of that, one bit will be for it will be signed bit. Okay, you cannot use it. So you are remaining with 31 bits. So first go and check out whether such a number you can even store that or not. Okay, I have done the calculations. I will show you in some time. But again, this is a homework for you. Please do the calculations and keep it ready, and then match with my calculations. Okay, I've already shown you yesterday in yesterday's video. Please learn those things and try to do that in your interview also. Those things will be getting some attention from the interviewer. Remember that part. Okay, how many bits are required to hold this much number? Okay, this much big number. Right, now coming to today's question. You are given a zero index array nums1 and nums2. Okay, consisting of non-negative integers. There exists another array nums3. Remember, nums3 is something that you have to calculate. It is not given as such. Okay, there exists another array nums3 which contains the bitwise XOR of all pairings of integers between nums1 and nums2. That okay, we will see that what this means. Okay, that is every integer nums1 is paired with every integer in nums2 only exactly once. Okay, now return the bitwise XOR results of all the integers in nums3. Okay, it's a I will say pause the video, see the question once in the image itself, in the video, in the screen. Okay, screen itself you can see it what it is, and then let us see the example one. So if you see what is happening, they are saying that every integer in nums1 has to be XORed with every other integer in nums2. Okay, that is every possible pairing has to be done in such a way that okay, each pair is formed only once. Okay, let us see how it works. See here, 2 will be paired with 10, and then with 2, and then with 5, and then with 0. Okay, in that way we ensure that 2 is paired with every integer in nums2. Okay, similarly 1 will be paired with okay every integer in nums2. First it will be paired with 10, then with 2, with 5, and with 0. Similarly 3 will be paired with 10, with 2, with 5, with 0. Okay, when I'm saying pair, what it means, you have to take the XOR. Okay, you have to take the XOR. Now each of these exhausts should be stored in an array called num3. Okay, that is what is a num3. Okay, so what is a num3? It contains the bitwise XOR of all pairings of integers between nums and nums2. Okay, so can you quickly tell me now? Please pause the video and tell me how many integers are going to be there in num3. Okay, I can give you 1 or 2 seconds, but please can you tell me if you have understood the question? If you have not understood, pause the video, take a moment, and then tell the answer, and then start the video again. Okay, so the answer is going to be the length of this multiplied with length of this. Okay, since every integer in num tree is going to be a pair. Okay, so how to form a pair? A pair will form when I take integer from this and I take integer from this. So how many such pairs can be formed? It is going to be, in this case, 3 into 4, okay, which is 12. So num3 is going to have 12, integers, and among those 12 integers, now see this part, this is the num3. Just count how many values are there. There has to be 12 values here. Okay, then you have to take XOR among all these values. Okay, then you are going to get an answer which you have to return. Okay, as simple as that. So there are two steps. First of all, make a every possible pair between a number in nums1 with a number in nums2. Then when I say pair, it means XOR. Okay, then record the results here. Okay, there will be m1 into m2 results. Okay, m1 is the length of nums1, I can say like m2 is the length of nums2, something like that. Okay, so now we get all these things. Now we have to again take XOR among all of these. Okay, remember this XOR will be among all of these. The previous XOR was between two integers only. Okay, as simple as that. So this part you have to do. Then you have to get an answer which is going to be the answer that you have to return. Okay, you can go through examples and constraints I've already explained to you. So if you see, this is going to be a very very tricky question. Like I am challenging you, can you do it using see, don't see the optimal solution and all, review that, can you do it without that? Okay, like if you don't know the optimal solution, let us say, will you be able to do this question? That is the main thing. Remember that you cannot be going for optimal solution just like that, okay, in interview, right? Because that is not something that is very much expected from everyone, right? You have to go there, you have to reach there, maybe you have to show the calculation, then reach there. Okay, as simple as that. Now I will show you one of the solution that I have coded, and then I will show you the brute force solution. Okay, as simple as that. So let us go with that. Remember, this is not the optimal solution, but this even clears all the test cases. Okay, even this solution clears all the test cases. Okay, let us see that. I am capturing the length of nums1, I am capturing the length of nums2. Okay, they are called n and m, right? Next, now comes to the calculation part. See this part now. Okay, the highest value in this is going to be 10 power 9. Okay, 10 power 9. So in order to store 10 power 9, how many bits do we require? So it will be something like 10 power 9 is almost equal to 2 raised to power n. What is n? N will tell me how many bits are required. Okay, so if you apply log on both sides, it will be 9 log 10 is equal to n log 2. Okay, now if you shift the log, you will have n is equal to 9 into log 10 divided by log 2. Okay, now if you calculate what is log 10 divided by log 2, you are going to get 3.32. You have to just multiply this with 9 and you are going to get 29.89. Okay, if you take the approx, you are going to get 30. That means 30 bits should be more than enough. When I say 30 bits, it means 0 to 29 bits. Okay, as simple as that. So 30 bits should be more than enough to store the even the highest value given here. Okay, as simple as that, right? So in my calculation, you will see that everywhere the number 30 is coming. Okay, as simple as that. Okay, now what is happening? See, I am going to have a bit map, okay, which is going to have around 30 key value pairs. Okay, remember, since I am going to consider for every number I am going to consider 30 bits. For that reason, it will be having 30 key value pairs. Okay, what is each key going to do? Each key is having see, each key is again a key value pair. That is, see, okay, I will print and show you. That is, it will look something like this. Okay, let me show you. See, this is for the nums one. Okay, this is for the nums one. Okay, what it means? See this part. What it means for the bit 0. Okay, for bit 0. See, when I say nums1, I mean all the numbers here. Okay, that means I am going through each of the numbers in nums1. Okay, then I will calculate among these three how many ones are present in the zeroth bit of them. Okay, that is, I will calculate the number of ones. That is, yeah, if a one is present in the zeroth bit of two, then if a number is one is present in the zeroth bit of one, if one is present in zero bit of three, if one is present, I will record them here. Okay, so the zeroth bit among all the elements of nums1, how many ones and zeros are present? So zero is present in one is present in two. Okay, I will show. I will show you these calculations now, but this is just for understanding. I'm showing it to you. Okay, so for the zeroth bit, this is the overall picture. Okay, that is, among all the numbers, zero is present in the zeroth bit in one number, and one is present in the zeroth bit in two numbers. Similarly, for the bit number one, okay, zero is present in one number, one is present in two numbers. Okay, and so on. For bit number two, zero is present in three numbers, one is present in zero numbers. Okay, and so on. Right, till 30 it will go. Okay, I mean zero to 29. So till 29 it will go. And similarly, we are going to do for nums2 also. Okay, for nums2 also we are maintaining it. Okay, let us see how it is being populated. Okay, so as you can see in this scenario like this, so every pair, that is for every bit, I am having a key value pair where the keys are zeros and ones. This will tell me how many bits are having, that is how many numbers are having that particular bit set to zero and how many are having set to one. Okay, as simple as that, right? I'm again declaring answer which is initialized to zero. Now I'm going through every element in nums1. Okay, let me zoom in so you get a clear picture. See, I'm going through every number in nums1. Okay, now I'm going through each of the bits in each of the elements. Okay, for example, let us say I'm in the first element of nums1. I am going through all the 30 bits of that. Okay, that is 0 to 29 bits. Now This part I already explained in yesterday's video. What we are doing, I am only bothered about the jth bit currently. Okay, the jth bit. Okay, so what I will do, I will move the jth bit to the bit number 0. Okay, that is, this is called a right shift. What I'm doing, I'm right shifting it. This will ensure that the bit that I'm considered with, okay, that I'm interested in, let us say the jth bit now comes to the 0th bit position. Okay, jth bit will now come to the original 0th bit position. Okay, then I'm going to do AND with 1. This will tell me whether, see, this whole calculation is to check whether the jth bit has a value 1 or 0. Okay, so if it is 1, what I have to do, I have to go to the jth key and I have to go to 1 and I have to increment it by 1. Okay, as simple as that. Let us say if it is 0, what I have to do, again same thing, I have to go to jth bit. Okay, go to 0, the key number 0, and increment it by 1. Okay, as simple as that. The same thing. Okay, then I'm printing it. Okay, see, this will be more clear in some time. Just wait for it. I will show you the example on calculations. The same thing I'm going to do for nums2 also. I'm going for each of the nums2. Then this part is again the same. Only thing is here nums2. See, the variables are different, right? Here it is bitmap for nums2. Here it is bitmap for nums1. Okay, as simple as that. I'm going to nums2. I'm just checking if the jth bit in the current number is set to 1. Then make this key increment by 1. If it is set to 0, increment this key by 1. Okay, as simple as that. Now I will show you the calculations. Okay, then we'll go to the rest of the solution. So see this part. Okay, let me zoom in again. Yep. See this part. See, this is the nums1 in example number 1. Okay, 2, 1, and 3. How to write 2, 1, and 3 in binary? See, 2 is written like this, 1 is written like this, and 3 is written like this. Okay, so how is the bitmap going to read? See this part. Let us consider only the 0th bit as of now. Okay, so see, this is the 0th bit. Okay, so here one of the 0th bit is 0. Okay, here 1, here 1. So in the 0th bit among all the numbers, two of the numbers have 1 in the 0th bit, and one 0 is there in the 0th bit. Okay, so for the 0th bit in nums1, what you have to write? 1 is present in 2, okay, and 0 is present in 1. Okay, similar to that. Now coming to the other part, see the bit number 1. Bit number 1, 2 bits are set. Okay, in the, for the bit number 1 among all the numbers, 2 bits are set and 1 bit is not set. Okay, so come to 1. Okay, 2 bits are set, so 1 will be having a value 2 and 0 will be having a value 1. Okay, and so on. Similarly, see here bit number 3 is not existing, that means it is 0. Okay, you have to assume like it is 0. So if you see for, okay, bit number 2, if you see bit number 2, what will happen is all the bits in all the numbers will be 0, so it will be 3. Okay, see, and for and so on, right? For bit number 3 also same thing, all the bits will be 0, so here 0 will be having value 3. Okay, and so on. Now come to nums2. See this part. Here 10, 2, 5, 0. Okay, this I've written in the binary form for each of them, so in the same order. This is the 10, and then 2 and 5 and 0. Okay, now can you quickly tell me for the 0th bit how many ones are there among all the numbers? So as you can see, only one number has the 0th bit as 1. Okay, so for the 0th bit, what I have to do, sorry, yeah, so for the 0th bit, what I have to do, see, 0th bit is set to 1 for only one number. Okay, as simple as that. And for all the rest of the three, 0th bit is 0. Okay, so here it will be 3, right? Now come to bit number 1. So bit number 1, how many bits are set? Only two bit number 1 bits are set. Okay, so if you see the bit number 1, how many bits are set? Bit number 1 bits are two of them are have this particular bit set. Okay, now come to bit number 2. Bit number 2, if you see, only one bit is set. So if you come to bit number 2, only one bit is set, so 1 is equal to 1. Okay, as simple as that. Now coming to bit number 3, only one bit is set again. Let me zoom out. Okay, yeah, as you can see, bit number 3, this is the key 3. In that, if you see, 1 is having value 1. Okay, that is all, right? Now I have to see how to do this calculation. Now see this part. What is XOR? I hope you are aware of XOR, because see, these things I've already discussed in yesterday's video. That's why I don't want to go into detail of that. See, XOR means that whenever the bits are not same, the result is going to be 0. Whenever the bits are, okay, sorry, whenever the bits are not same, the result is going to be 0. Okay, let me write it here again. But see, these things I've already taught. That's why I am not interested in teaching them again. See, for example, if you have 1 and you're doing XOR with 1, okay, so what will happen? Since the bits are same in this case, you are going to get a result of 0. Okay, now can you quickly tell me, let us say one of the bit is 0 and other bit is 1. So in this case, since the bits are different, so you are going to get a result of 1. So okay, so I'm showing you only two cases. There are other two cases also. See here, whenever the bits are same, the result will be 0. Whenever the bits are not same, the result will be 1. Okay, just know this part. This is the XOR. Okay, this I'm talking about XOR. Okay, as simple as that. Now coming back. See, now you have to face, now you have to put your whole attention on these things. Okay, on these things. Now we are going to get the nums3. Okay, now we are trying to get the nums3, right? So what is nums3? Nums3 is going to have the XOR results of the pairs of nums1 and nums2, right? See this part. Now my interest here is, see, just one more thing that I want to tell you, that see, once you get the num3, what you have to do, you have to simply do the XOR. So what is XOR, by the way? XOR I've explained you. See, what will happen is, see, currently I've explained the XOR of two. Okay, two numbers, but you can have more than two numbers also. So in that case, what will happen? In that case, what will happen is, see, if even number of ones are present, the result will be 0. If odd number of ones are present, the result will be 1. Okay, as simple as that. I hope you are getting this point. See here, even number of ones are present. For that reason, the answer is 0. Okay. Let us say I include one more one. Okay. I just included one more one. So what will happen now? The answer will become 1. I hope you are getting. Okay. So it depends on how many same digits we have. Okay. How many same digits we have. Okay, same bits we have. So I'm trying to get this part. After getting this part, it's very very simple. Okay, why it is simple? See, if I know that the bit number 1 is set in, let us say, even number of digits, okay, even number of numbers, so I'm damn sure that that will be 0 in the answer. Okay, because it is even, so it has to be 0. If it is odd, that has to be 1. Okay, that is the one of the properties of XOR. Okay. Now see this part, same logic I'm going to apply now. So how to get 1? See, if in the nums one, okay, so see, this is, I'm only talking about 0th bit now. Okay, 0th bit of nums one and 0th bit of num two. Okay, so this is the overall result. So let us say, in the nums one digit, wherever zeros are present, if that is multiplied with a digit, a number in nums one where the first bit is set. Okay, so I'm going to pair it like this. Okay, so the 0 of this will be paired with 1 of this, and similarly the 0 of this will be paired with 1 of this. Okay, why I'm doing so? Because if the bits are not same, only then 1 will be produced. Okay, for that reason we are doing it. Okay. So we are trying to get in the result how many numbers will have their 0th bit set. Okay, what is that number going to be? See here, so it will be 1 into 1, which is 1, plus 2 into 3. Okay, 2 into 3 6, and plus 1 is 7. Okay, so in the result, that is in the what is they called, num3. Okay, in the num3 there will be 7 numbers whose 0th bit will be set. Okay, there will be 7 numbers whose 0th bit will be set. Now if we do XOR, okay, there are 7 ones. Okay, now if you do XOR of a number with itself odd number of times, since 7 is odd, what we are going to get? We are going to get 1. So we can conclude that in the result, that is in the answer, the 0th bit is going to be set. Okay, I will again repeat what I'm doing. See this part. Our aim is to to see how to produce 1 in the 0th bit. Okay, how that can happen? If I take a number in nums1 whose 0th bit is not set. Okay, whose 0th bit is not set. Similarly, if I take a number whose 0th bit is set, so if I multiply these two, the result will have 0th bit set. Okay, because it is 0, it is 1. Okay, so 0 XOR 1 will be 1. Okay, as simple as that. Similarly, if I take a number in nums1 whose 0th bit is set, and if I take a number whose 0th bit is not set in nums2, again their 0th bit will be set in the result. So that is what I'm saying, how many such results can be produced. So it is 1 into 1 plus 2 into 3. Okay, so 6 plus 1, which is 7. So there are 7 numbers in the result whose 0th bit is set. Since 7 is odd number, so we can conclude that in the answer, that is in this particular answer, the 0th bit is going to be set. Okay, now let us see the rest of the numbers. See this part, now talking to bit number 1. Okay, bit number 1, so it will be 1 into 2, okay, which is 2, plus 2 into 2. Okay, so 2 plus 2, sorry, yeah, 2 into 2 will be 4, and 4 plus 2 will be 6. So if you see, there are 6 ones in the result. Okay, there are 6 numbers whose bit number 1 is going to be set. Since 6 is an even number, so in the result, the bit number 1 will be set to 0. Okay, bit number will be set to 0. Okay, XOR of a number with itself even number of times will be giving 0, so the bit number 1 in the result is going to be 0. Okay, now let us see for the bit number 2. For the bit number 2, now I'm going to see 3 into 1, which is 3, plus 0 into something. Okay, 0 into something is not useful to us. Okay, 0 into something will be always 0, so we are not going to bother that. It is going to be 1 into 3. Okay, so 1 into 3 is 3, which is odd number. So 3 number of ones, since 3 is odd number, so the bit number 2 will be set in the answer. Okay, now coming to the other part, see this part. Okay, let me just pull it here. Yep, now we are seeing for bit number 3. See this part, it is going to be 3 into 1. Okay, plus 0 into 3. Okay, since it is 0, I'm not going to consider that, so it is going to be 3 into 1. Okay, so 3 into 1 is 3, so against 3, so since 3 is odd number, so the bit number 3 is also going to set in the answer. So if you see, the 0th bit is this, the bit number 1 is this, the bit number 2 is this, and bit number 3 is this. Okay, just write it. So this is the binary representation of the answer. Okay, 1101. Okay, so this one, this one, this 0, and this one. Okay, so this is the answer. Okay, 1101. If you take the decimal of it, what you are going to get? You are going to get 13. Okay, so we are going to get 13. See, this is the position value for 8. So 8 plus 4 plus 1. Okay, 8 plus 4 plus 1, you are going to get 13. So 13 is going to be your answer, and you are getting it here. Okay, so this is one such technique that you can use to get the answer. I agree, this is not the optimal way, because they have a trick to get the answer. Because of that reason, this is not looking optimal, but fine. So this is also one of the algorithm that you can use to get the answer. Okay, I have tried my best to give you all the details. Even if you are not able to understand in the first go, remember, this video is already there, always there in the YouTube. Please, like, if you have any doubts, again, like, pause the video, go through these notes. That's why, see, I always provide very proper notes, so that this will be there in the comment section. You can always copy paste in a notepad, or maybe, like, yeah, just write it in your own notebook even you're seeing this video, and then understand what is happening. Okay, then run this program. This code is always there in the comment section. Just take it, run it, add some print statement, and then try to understand what is happening. Okay, as simple as that. So yeah, friend, that was all for this. Okay, now coming to the optimal solution. See, optimal solution, I'm not going to spend much time. This is like a, I can say, the cheating way of doing the things, because yeah, like these things, see, if you are a coder, when you see the code, you are supposed to code, right? And when you see, see the question, you are supposed to code. Then why you have time to do this much of maths and all that? So I'm not a big fan of these things. But again, this is just a trick, so it is my responsibility to teach you the most optimal way also. So I'm doing it. Okay, so see this part. Okay, let us say n is the length of nums1, m is the length of nums2. Okay, now see this part, let us do these calculations. Okay, so we are bit of maths is now going to come. I'm now going to teach maths also in my videos. See this. So this is the nums1. Let us say the elements are a1, b1, c1. Similarly, this is the nums2. Let us say the elements are a2, b2, and c2. We'll only take the case of a1, and the case of rest of the stuff will follow. Okay, we are only going to take the case of a1 and a2, and rest of the case like b1, c1, and rest of the case will be following. Okay, as simple as that. So let us say n is the length of nums1, m is the length of nums2. Okay, very simple. Till now everything is clear. Okay, here I'm giving dots because it can be any number of, see, the numbers can be anything, right? That's why the we are taking variable, right? It's not a, a constant stuff, right? It can be changing. For that reason, we're taking variable, right? Now, can you quickly tell me how the nums3 is going to look like? Nums3 will be looking like a1 XOR with a2. This is going to the first element. Okay, this is the first element. Then a1 XOR with b2. This is going to be the second element. Okay, similarly a1 XOR with c2. This is going to be the third element, and so on, right? Now b1 will come. b1 XOR with a2, b1 XOR with b2, b1 XOR with c2. Then c1, c1 XOR with a2, c1 XOR with b2, and c1 XOR with c2, right? All those stuffs will come. I'm not writing everything here. Okay, I'm just trying to focus your attention on a1. Just focus on a1 as of now. Okay, so now among all of these, again we have to take a XOR. Since num3 we have got the final, what is the question actually? If you see, we need a bitwise XOR of all the integers in num3. Okay, so we have to again do XOR. So if you do the XOR now, this is going to look like this. Okay, this is the first element, XOR with second element, XOR with third element, and so on. Okay, and so on, right? Now I'm just saying, like, let us rearrange it. Okay, remember, the XOR operation is, see, the order in which we are doing the XOR, it's not important. Okay, that is the property of XOR. For example, let's say if you do XOR of n1 XOR n2 is equal to n2 XOR n1. Okay, that is the order in which the numbers are present, doesn't matter. Okay, as simple as that. It is just like a plus operator. If you do 3 plus 2, or if you do, 2 plus 3, both are same, right? Something like that. Okay, as simple as that. Now see this part, I'm just rearranging them. Okay. So A1 is here also, A1 is here also, and A1 is here also, and so on. So I'm writing all the A1s together. A1 XOR A1 XOR XOR, and something like that. Okay, and so on. Similarly, since A1 is here, for B1 also same case will come. Okay. For B1 also same case will be coming. Okay. Now the question is, okay, same thing. Okay. Now coming to this part, see A2. A2 also, if we write all the A2s we are taking common and something like that, it will look like this. Okay. A2 XOR A2 XOR A2, and sometimes like that. Okay. And so on. So the thing is, how many A1s we are going to have in total? See this part, since the length of this nums is going to be m. Okay, so we are going to have m a1s being XOR together. Okay, so see, if you see a1 XOR a1 XOR, this is going to be m times. Similarly, b1 XOR b1 XOR b1, this is going to be m times. What is b1? B1 is coming from here. Okay, so all the elements of this nums1 are going to XOR with themselves m number of times. What is m? M is the length of nums2. Similarly, if you see for a2, b2, all of them are going to XOR n number of times, where n is the length of nums1. Okay, so this is how it will look like. Okay, a2 XOR b2 like this n times, b2 XOR b2 like this n times. Okay, and so on. There are other steps also, right? Now coming to the XOR property, see, if this m is even, then this whole step will result into zero. Okay, since a number, being XOR with itself gives zero. So if you're doing that for even number of times, we are going to get zero again. But if m is odd, then we are going to get a single even. Okay, so that is the basic idea. Same thing here, if n is even, okay, this whole stuff, that is a2 XOR a2, all these things will give zero, and same is the stuff here. Okay, but if n is, okay, just a second, if n is odd, what will happen? For example, see, there are three b2s. Okay, let us say n is odd, right? 3 is odd number, so these two will cancel itself. Okay, these two will cancel itself, a single b2 will be remaining. Okay, as simple as that. So that is the idea that we are going to try now. So see this part, by what we are doing. There are four cases now. Okay, for each of them, now we are going to see the answer. Okay, see, if n1 percentage 2 is equal to 0, that is n is going to be even. Okay, if n is even, where the impact will come? Impact will come on the digits of nums2. Okay, on all the digits on nums2, they will be useless now. Okay, we have to only focus on nums1 now. Okay, only on the values of nums1 now we have to focus. Okay, see this part, if n2 is equal to 0. Okay, fine. So these are the two cases where n2 is equal to 0. Okay, what are the two cases? Whether m is equal to 0 or not. So if m also is 0, then even, see this part, These numbers are gone because n is even. Now even these numbers are gone because m is even. So the answer is going to be 0. Okay. Since all the numbers are going to cancel themselves, the answer is going to be 0. Let us say if this is not the case. So n is even, but m is not even. Okay. So what will happen? See this part. If n is even, so these are all gone, but m is not even. So these will remain. Okay. So one time of each of these will remain. So a1 will remain, b1 will remain, all that will remain. So what are a1, b1? These are going to be part of nums1. So now we have to bother only about nums1. So see this part, what we are doing. I'm declaring answer equal to 0. I'm going through each of the elements of nums1. I'm doing a I'm doing answer is equal to answer XOR I. Okay, what is I? I is the element in nums1. Then finally return the answer. Okay, so this is one such case. Now, if the if of this, what is the if of sorry, what is the else of this? When n is odd. Okay, so if n is odd, we again have two cases. Okay, if n is odd and m2 is 0. Okay, if n is odd, see this part. If n is odd, okay, and m2 is yeah, m2 is even. So if m2 is even, these two, all of these are gone. Okay, and but these will remain since n is odd. So what are these numbers? These are part of nums2. So now we have to only bother about nums2. So see this part. Since m2 is odd but n is even, what we have to do? We have to only bother about nums2 now. Okay, same thing I'm doing. I'm declaring answer equal to 0. I'm going through each of the elements in nums2 and doing I'm the same thing. Okay, answer is equal to answer XOR I, and then I'm returning the answer. If the now this else condition, what is happening here? N is also odd and m is also odd. So this is the else condition when both of them are odd. In that case, what I have to do? I have to do both the calculations now. So each of the numbers will exist now one time. Okay. So I'm going through all the elements in nums2. I'm taking XOR. That's now answer is 1. I'm quitting with 0. Answer 1 will have store the XOR of all the numbers in nums2. Similarly, I'm creating answer 2. Answer 2 will store XOR of all the numbers in nums1. At last, I'm doing answer 1 into answer 2. Okay. Answer 1 XOR answer 2, and then I'm returning it. So these are the 4 cases that can come. Okay. I've shared all the cases here. Okay. If n2 is even, we have 2 cases. Okay. Similarly, if n2 is odd, we have again 2 cases. Okay. So this is the case 1, this is the case 2. And for each of them, what is the answer? I have shared it here. Okay. You can run it on your own. You can check it out. Okay. Yep. And if I show, like, yeah, this solution that I'm showing currently, it will be, beating 100% of the test cases. In my case also, let me show the submissions. Okay. This was the one. So if you see this one, it is beating 100% of the test cases. Okay. As simple as that. And the one which I showed you previously, it is taking around like 1500 milliseconds time, the one which I showed you in the first. Okay, so yeah, both of these are good solutions, but yeah, the second one that I showed you, I'm showing currently, is a tricky one. If you know the trick and if you know these things only, then you will be able to come to it. But again, it is a risk. Okay, it is a risk to take time and try these things and observe. Only if you have a pen and paper, I guess you will be able to do these things. Okay, otherwise if you are only given just a laptop to code it, I don't think you will have time to come to these kind of solutions. Okay, as simple as that. Okay, because if you are good in programming, you will always try to go for these kind of solutions. That is my intuition, but yeah, it differs from person to person. You can share your thoughts also maybe in the comment section. So yeah, and that was all for this particular video. This was a very nice question according to me. Remember, most of the people will be teaching you this solution, I am damn sure about it, but no one will teach you this kind of solutions, which is not something which everyone can get. Okay, this solution is not there in any official solution or any other submitted solutions. This is something that I've created on my own, and I'm showing it to you with all the details of all the calculations. Okay, so yeah, that was all for this video. If you like my efforts, yeah, please do subscribe to the channel. It takes a real lot of efforts to see. If I can simply show you whatever is given in official solutions and I can end the video. Okay, but that is not my objective. My objective is also to grow with you. Okay, so that's why I always try to do something different, and if I succeed, I bring that to you. Okay, as simple as that. This question, yeah, when I saw initially, I felt okay, here maybe like we don't have any other options to solve. But yeah, then I figured out the solution and it really worked. There could be a case that it might not have worked. Okay, but fortunately this worked and I showed you the solution. And this is something I am guaranteeing you, no one will teach you this. Okay, these things, like, see, only those who have faced that interview, who have lost some marks in interview, only they will be knowing these things and they will be teaching you this. Okay, other people who have not seen this kind of scenarios in interview, they will never teach you these things. Okay, that is how to estimate how many bits are required to capture to a whole the max value that can come. Okay, so in this case 10 power 9 is the max value. See here, so for that reason, how many bits are required? Okay, how many bits are required? So in my calculation, I can show that 30 bits are required. So that's why I can confidently do 30 for all my calculations. Okay, if you see, I'm only doing the calculations till 30, which is 0 to 29. Okay, so these things no one will show you, because either they are not doing to teach you the right thing, or maybe they are just doing to get some subscribers. That is not my aim. My aim is to continue coding and grow in the coding, and to provide a quality video to all of you. Okay, as simple as that. So if you like my efforts, please do subscribe to the channel. This really gives us a lot of motivation to continue further. This is my 86th day, consecutive day of uploading a video, and let us hope that it continues further. So yeah, friends, see you tomorrow. And if you like, please subscribe. This really gives a lot of motivation to continue further. Thanks a lot.